character string, string. Okay, so you already know about the character string, I think. So because we have already talked about the character string in our previous class. So something written in between the quotation mark. It may be single quotation or it may be double quotation. The same thing. Yes, so whenever we write something in between the quotation mark, that is called character string. A string of characters, and character strings are represented by the ASCII code. Okay, ASCII ASCII code. A string of character that can be represented by ASCII codes. So you can write that if you like. So a string, what is character? String. So it is nothing but a string of a string of character, a string of characters that can be represented by a ASCII code. Okay, so a string of characters that can be represented by ASCII codes. Okay, so character strings are represented by ASCII code, and you know that character string are represented by quotes. So if you want to use the character string in your program, what you have to do, you have to write just in between the quotation. Single quotation or double quotation, both are okay. Okay. So now, so let me give you some example of character string, how we can represent the character string. Letters, L E double T E, letters, that is my name. So letters is my name, and suppose I am going to assign an array. Yeah, I'm going to assign an array. So letter DB, and the character string, suppose it has character string capital A, capital B, and capital C. These are the three letters. Okay. So you can see this is a byte array, and how many bytes we have here? Can you say how many bytes this byte array has?
8 bytes, sir.
No. How many bytes this byte array has? Letters, that is the name. So you can call this array by the name letters. So how many bytes this byte array has? Who is this dot? That is your name. You have to write name and ID. Why after so many classes you are joining by dot? Yeah, who are you? Who are you? Dot. No answer.
Sir, he is dot dot.
Yeah, no answer. No answer. Please answer. Who are you? So yeah, so letters, how many bytes this letters has? This array has how many bytes? Anyone? Dot dot. So you cannot join by dot dot. You have to write your name and ID. That is the rules. Forty-one hex, 42 hex, and 43 hex. Look, now it is clear, right? It has 3 byte because in the position of value there are 3, and all are bytes. That's why this is a 3 byte array. Okay, so assembler differentiates. You know that assembler or emulator, they differentiates between upper and lowercase. Like if uppercase and lowercase are different thing. So we can write that assembler differentiates between upper and lowercase. Okay, so assembler differentiates between upper and lowercase. That means uppercase and lowercase are not same. So if you want to write, so it is written in uppercase. If you look at here, if you write the same program in lowercase, you can write letters dv and lowercase small a, small b, small c. So look, so lowercase abc and uppercase abc, those are not similar. So those are different things. So what will be the equivalent ASCII code for lowercase abc? Can you say what will be the equivalent ASCII code? Yeah, what will be the equivalent ASCII code for lowercase small abc? So letters, you can write this by letters. db small abc. So what is small abc? That is 61. Yeah, 61x, 62x, and 63x. Okay. Okay. So we assigned two array with 3 bytes, one for uppercase and another for lowercase. Okay, so we know how to assign byte variables, we know how to assign word variables, we know how to assign arrays. And you also know that we can combine the uh, character string and number together from our last class, right? So now how can we assign constant? Constant means you know that the value always remains same. Like if I give you an example, that is pi is a constant. What is the value for pi? So pi is a constant, right? So what is the value for pi? Can you remember?
So
3.1416, sir.
3,
3.1416.
yeah,
3.1416.
yeah, 3.14. So to be exact, it's 22 by 7, right? Or you can write 3.1416. That is also correct. So if you want to assign constant value, something like pi, and in assembly programming, there are also many constant value uh, that is for their programming. I mean, convenience. They have some program. I mean, constant value. That is for the programming convenience. So there are many constant values. So let's see how we can assign the constant value. So it is called
Sir, could
named
you please
const.
go to the previous slide?
Yes, wait, please. Named constant. Okay.
Done, sir.
Okay. So how can we assign a name to a constant value? How can we do that? It's like, so to assign a name to a constant, we have to use EQU syntax. The syntax is EQU. To assign a name to a constant, and what we have to do, we have to use EQU. EQU. So the full form of EQU is equates, but you have to write EQ. You don't have to write equates. Pseudo of. So this is a pseudo of code. Okay. So EQ pseudo of code. So how can we assign constant? You know that it's like variable. The syntax is you have a name. So syntax. What is the syntax here? Syntax. So like variable, word variable, byte variable, and array. It always starts with a name, so it should have a name. And after that, in the place of db and dw, we have to replace db and dw by equ. You know, when you assign db and dw, that those are variables. I mean, the value of variables can be changed later, but when you write equ, that is a constant value, and this value will not change. We talked about some program, right? From the chapter 4, there are three, I mean, full program. You can look at those program and you can see there are some, they have assigned some constant value by EQU. You can check those. And you can also run if you want to run by emulator. So EQU is to assign constant value. It has a name and then space, then EQU, then space, and we have a value. Value is nothing but a constant. So name space EQ space constant. That is the syntax. Now, if you give example, you can also give some example for that. Example. So, for example, like we already said here, we have pi. Pi is a constant value. If you want to assign pi, you can do that simply. So, what do you have to do? You have to write the name. Name is the pi. Then you have to write eq. That means it is a constant value, and you have to assign the value. So, what is the value? 3.1416. Done. So, this is the pi value, and this pi value you can later use in the program anywhere in the program. So if you have 30 lines program and you can use that pi value, you can recall that pi value anywhere in that program. So that is how we assign constant value. So this language also creates some constant value depending on the need, uh, or depending on the necessary of the language. So let me give you some examples. Suppose LF means line feet. So if you want to go to a new line from the current line, so you need this constant. LF EQU. EQ means it is a constant value, and the value is 10, nothing but 10 decimal. You can write in decimal, it is 10, or you can write in hex, OAS, whatever you want. The value is nothing but 10. So LF is called line feet. You have to remember that LF means it is line feet. Okay, it is line feet. So what this actually this statement does, LFEQ, is what is the meaning of this? It assigns the const name LF to a hex. It assigns, first of all, it assigns, you already know that. Okay, it assigns the name A, assigns name LF to OA hex. Okay, it assigns the name LF to OA hex. Now we can use LF in place of OA hex. Okay, and anywhere in the program, like I said before, anywhere in the program. Okay, so you assign a name anywhere in the program. Okay, so you can, what that means actually. So it means that you can write this one. So move, suppose if you write normally a program like this, move DL, you know that is the low byte of register DX, low byte of register DX, you know that, and OA hex, that is the number. Now in the place of OA, you can also put LF if you want. That is also okay. Or you can write move DL comma LF. That is what you can also write. Okay, no? Okay, so you get the constant, right? So constant is some kind of number. You can see 3.1416. That is a number. You can look at here where that is another number. So you can see, you can guess that is constant, maybe a number always. That is not the case. So constant can be number and constant can be string also. So you can assign a string. I mean, a string can be also constant. String means the something written in between the quotation mark. That is called string. Okay. So string can also be constant. So let me give you an example. So I mean, you know what is the meaning of constant. Constant meaning value always remains same, right? That is the name of the constant. So constant may be string also. Constant may be string also. Suppose if you have prompt is my name, prompt, that is my name. There is no space. Okay. Prompt and eq, that means the value, whatever the value given here, that is a constant value. We can write type your name. Type your name. So this type your name, this is a string, and this string is a constant. Okay. Suppose if you assign a byte variable, you can write message db type your name. Also, you can use message db prompt. Okay. You can write message db type your name. Also, you can write what? You can just call the this I mean this value by by the name prompt. That is what you can also do. So how can you use this one? So you don't have to type your name again. So you just call by this prompt name. Okay. So okay, it means that, okay, let me give you the example. So you can write message db, that is a message you like to print. So message db, you can write type your name. Type your name. Okay. So in this way, you can write type your name. So you have to write down the whole thing. And if you don't want to write down the whole thing, so in that case, what you can do, you can just call this message by the name prompt. So you can write or you can write message db prompt, prompt prompt. Okay, so both are allowed. Okay, both are same thing. So you can write message db type your name. So you don't have to call that string again and again. So in the later part in a program, if you want to, you need that, type your name. If you want to print that, type your name, then you just call by the name prompt, because that type your name string, the name of that string is prompt. The prompt name is given by assigning a constant. Okay, that is how you can call this later. Okay, good. So there are many instructions in assembly language. So assembly language, this is a very old-fashioned language. Okay, but it is in our syllabus. Okay, so nowadays actually we don't. I think I'm not sure whether we use that much this one or not. But nowadays there are many
Sir,
more.
fast strike to open করা যায়?
Yeah, I can go there. Nowadays there are many more updated languages coming, like MATLAB is a good language. If you want to go outside, you definitely need MATLAB, and Python is a very good language. So if you study those, then I think you are good to go. You don't need assembly language. Okay, this is the first phase. And this is the second phase, and this is the last.
Okay, sir. Thank you, sir.
Okay, so there are many instructions in assembly language. I think we have already discussed that, and I think you already know this. So let's start with the move instruction, and we'll discuss some of the instruction out there in the assembly language. Move, how this move works. We have seen this maybe in lab, or here also we have written that. but how it is working actually, we have not studied this instruction in detail so far. So let's we want to study this move instructions in details, how actually it works. You know that is move means to move something, right? That is what you know. So it is actually used to transfer data between two registers. It can also transfer data between a register and a memory location, or you can move a number directly into a register or a memory location. So there are three tasks of this move instruction. Okay. So number
Sir,
one,
sir,
yes,
in last line, message DB prompt. Prompt, is it string, sir?
yeah, that is the name of the string. Prompt is the name of the string.
Okay,
You
sir.
can see
Then
there is the name.
it may be, sir, with quotation, sir. Then
Yeah, I think it will work without quotation because the
Sir,
string
without quotation,
is,
sir.
yeah, string is already the type your name is within itself.
okay, sir.
Okay, so transfer data between two registers. So why we move use we use move to transfer data between two registers. Okay, so by using move you can transfer data between two registers. If you want to see an example, you can write move ax is a register, you know that, and bx is a register, you also know that, so you can write that. So that is the number one use of move. The second use, so you can transfer data between a register and a memory location. To transfer data between a register and a memory location. So what do you mean by memory location? What do you mean by memory location? Yeah. So you know that memory location is nothing but variables. Okay. What is memory location? Memory location is nothing but variables. So memory location means variable. Suppose, okay, and you know that to transferring data between a register and a memory location, you first need to assign that memory location, right? So that means let me assign a memory location B. Okay, let's change the color. So suppose B, yeah, B is my memory location, and that is a word. Okay, that is a byte db, and the value is 34x. Okay, now we assign the memory location, and then we can transfer data between a register and a memory location. That means you can write move b comma x. Okay, so when you assign the memory location, then you can use, I mean, when you assign the variable, then you can use that variable in your program. If you don't assign, then you cannot use. Okay. So, and register, you don't have to assign register because register is already there in the processor. So we don't need to assign the register, but we have to assign the variables. Okay. Number three. Number three. So you can move a number directly into a register or a memory. To move a number directly into a register or memory location. Okay, so these are the tasks of move operation, right? The first, you can move data between two register, move data between a register and a memory location, and the last one, move a number directly into a register and a memory location. Suppose what is the example of that? Suppose you can write move a number. You want to move a number into a register. So you can write x, comma 1, 2, 3, 4. 1, 2, 3, 4 x. Okay, that is what you can write. Okay, so you know what is the task of move operation? There are three tasks of this move operation. Now, how can we write this move operation? What is the way? So we have already written the move operation. You know the how can we write the move operation, right? So it has a syntax. Syntax means the way we write this move operation. So the syntax is move destination, comma source. Okay, so that is the syntax. So move destination, comma source. So if you want to have an example of that, so let me give you an example from book. Another example, we have given already 3 examples. So let me give you another example from book. So example is move x, comma word 1. Word 1. So what do you think? Word 1, what is this word 1? It is a register. What do you think?
It's
What?
maybe location, sir.
Yeah, it's a variable, or you can say it's a memory location. And by the name, you can guess that it is a word variable, right? Not a byte variable. So the content of register, what will happen? What will happen here? Can you say what will happen if you write move x, word 1? What the action it will perform?
So from the word1 location, data will be moved to AX
Right.
register.
Yes. So you can say the content of register AX are replaced by the content of memory location word 1, right? That is what we can say. And what will happen to the content of word 1? It will change or it will not change?
So not change, maybe.
Yeah. Yes. So it will not change. So the two things it will happen. So the first, the contents of register AX are replaced by the content, you know that word 1 is called a memory location, or it also called by variables. So we use these two terms for the same thing. So are replaced by the content of memory location word 1. Okay, now the second thing is, you already said that the content of word 1 are unchanged. The content of word 1 are unchanged. Okay, we have given R, so you can write contents. So the contents of word 1 are unchanged. So that means it will not change. Rather, a copy of word 1 is sent to X. Rather, what will happen? A copy of word 1 is sent to X. Okay, so that is the task this move operation performs. So we studied this move operation in details right now. Okay, so I mean, if you want to look it by the diagram, you can see, suppose before you have this content, and that is the before case. Suppose A has this content X, that is my register X. So what will the value of X? 0006, suppose. Okay, that is 6. 0006. Let's consider X as 0006. And word 1, take word 1 here, 0008. That is word 1. And this is the before performing the move operation. Now when you perform the move operation, then the content will be updated. The X content will be updated, word 1 content will be updated. So this is word 1.
Sir, maybe we're running out of time, sir.
And this is X, yes. So after, so can you feel these blanks? What will be the value of X and word 1 after? Okay, please say. What will be the value of X and word 1 after the move operation?
Of X is 0008.
X will be 0008. Good. Yes.
Word on still remains same.
Yeah. So word 1 will remain the same. So it will 0008. Okay. Good. So okay, we have 2 minutes left. Okay, we are going to move to the next page. You can take screenshot.
Screenshot done, sir.
Okay, good. Okay, so let me show you. Okay, so you get the idea. So if I like to show you another thing. So suppose if you write this one, what will happen? Move H, comma, yeah. Then what will be the value of H after? It falls in the third category. You can see here. The third category is to move a number directly into a register. To move a number directly into a register. It falls in the third category. So if you write move H, comma, quotation A, what will value A will get? What the value A will get? Yeah.
Sir, 10.
No.
10.
No. Yeah. Anyone say it, please. Okay. We're running out of time, so take screenshot. Done. Okay, so what the value it will get? Say
8, sir.
no.
Sir, screen দেখা যাচ্ছে না স্যার?
Oh, okay, okay. Okay, so it's gone actually. Move move a h comma a. Say what the value is will get. And if you write, so let me give you another one. Suppose if you write this one, move ax comma a. Move a x comma base. Okay, tell me what the value, the first one, a is what will the value for a is for the first case, a is equal what? That is my question. The second case, what will the value of x equal what? And third case, what will be the value of x?
Sir, for first case, will be A, letter A. The second case also small letter A, and third is 10.
No, if you put a is equal letter a, that will be same as like hex a. It will not be a. Why it will not be a? Because it is same as hex a. The third case. This is the third case. The first case, second case, and this is the third case. Ibrahim Kaji said, Ibrahim, yes. Yes, sir. Say something.
Sir, I don't get you properly, sir. There is a network problem.
Hey, Hafiza Khatun, how are you?
Sir, fine, sirs.
Yeah, say, what will be the value for 3 case?
Sir, 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 A is or AX, sir.
Yeah, what did you say?
Sir, A is.
Okay, I think there are some problem.
Yes, sir.
Okay, no problem. You can mute your microphone. Okay. Okay, so Ronnie, how are you? Ronnie Rani. Ronnie Rani is not there. Mominul, are you there? Mominul is in campus or okay. Nobody is responding. Ifat, are you there?
Yes, sir.
Okay, say what is the value for case 1, case 2, and case 3?
Sir, A is equals to A
A is equal A. That is what you said. Okay. A is equal A. Then
AX equals to small letter A.
small letter A. Okay. Then okay. Let me give you another case. Case 4.
Hello.
Yes. Yes. I can hear you. So I am giving you another case. Move X, comma, small a hex. Actually, doesn't need small a, capital A doesn't matter. It's always a. Yeah, that is you said a. Okay, what about the third case? If Ifat, are you there? Prashanjit, you want to say something? Prashanjit, Ifat.
Sir, I have
What is?
not opened.
Okay. Third case, Ifat, say the third case. What will be the value for third case?
Sir, sir, AH.
A. That is not the thing, correct? If you write A is and small a, capital A, those are same, Small a equal capital A equal A's. All are hex number, hex A. Whether you write in small letter, capital letter, those are all hex number.
X
That
maybe.
means, yes, Sonia. Sonia, say.
Five.
Okay, what did I say you? What did I say you? About this thing. When you write something in between quotation, that is called character. And register gets what number for characters? When you write something in between quotation, that is called character. And register get what number for character? Suraya? Suraya, how are you?
Yes, sir. Fine, sir.
Sir.
Yeah, when you write something in between quotation, then register get character, Suraya. So for character, what number you get? Hello?
Yes, sir.
Yeah, say. For character, what number you get?
স্যার কোটেশনের মধ্যে যেটা থাকবে সেটাই নেবে স্যার।
Yeah, that is called character or ASCII code. For that, what number we get?
It's a constant number, sir.
Why you are saying constant numbers? What number? Tell me the number.
Sir, A capital A is 65 and small a is
A into
97.
Yes, Sonia?
sir, maybe it is big letter A and small letter A. A into small letter A. Sir.
Okay, so what we are studying so far? We already discussed that characters are represented by ASCII code. Why cannot you remember that? Characters are represented by ASCII code, and we also give the example for that. Now say, what will be the value of age?
Sir, capital A equal 65.
Not 65. We told last class, we told today's class. How can you forget that?
Sir, capital A equal to 41, sir.
Yes, it should be 41 hex.
Yes, sir. And small
Yes,
letter
sir.
A equal to 61 H.
And this one 0. There should be a 0. Okay. This one will be say. This is not character. This is a number. Now say.
So 10 each.
Why you are saying 10 ace? 10 ace and ace. Those are same. Those are not same. Okay, so I think you should study more. Okay, say what will be this one? Still no idea. Why? Okay, who just joined? So there are some people, they just joined before that means. Okay, Sabir Rahman, can you say? What is the result for third case? Okay. Okay, let me show you in emulator. I think that will be better. Yeah, so let me show you in emulator. Then you'll get the answer. Move, the first one is move AH, comma, what is that? Capital A, right? Capital A in between quotation, capital A. Okay, that is the first command, right? Can you see?
Yes, sir.
Yes, sir.
Good. Now let's check the answer. What is the value in register X? Can you see register X there written?
Yes, sir, we can see.
Good. So now the single step, just press single step. You can also run if you want. After running, you can check the value of register X. Now, what is the value of register AH? What is the value of register AH? 41.
41.
You know that this part is 40 A's, right? The high byte. And if you write AL, then it will go here in register AL. So the value of register AL is 41. Okay. So when you write move A's, A, it will get 41. It will just get the ASCII code. So always remember, when you write the string, when you write something in string, it will get the ASCII code. That is the point, nothing else. Now if you write AX, it will get 0041. Sorry, 0041. Yeah, if it is capital A. Okay, let's check that also. So run, look, 0041. So that because that is the capital A, so it's low. You are storing in X. So first go to the low byte, then go to high byte. High byte is 00. If you write a small a, what you will get? Tell what you will get.
61, sir. 61 is.
Yes, 0061. Got it?
Yes, sir.
Okay, now if you the third one, you cannot say that. Why you cannot say that? That I am not sure. Whether you can write a small a, if you want, you can write capital A. You will get the same result, by the way. So let's check by capital A. That is a number. It will get that number. It will not get 10. It will get 000A because A is the number, right? You see the result. It will get 000A because A is the hex number. It is written in hex number. Why should it get 10? If you want to get 10, you have to write 10 here. 10 hex. Look. Now it get 10. When you write in 10 hex, you get 10. Now, if you want to get A, you can also write 10, only 10. Then also you get A. Because you know that is the decimal number. When you write in 10, it will get A. Because 10 is a decimal number. you see 000A. So when you write 10, it will also get this number. And small a, okay, that is the last one. So small a hex, it will still get capital A there in 000A. I mean, look, 000A. Okay, so we're running out of time, so let's take your attendance. Okay, so 373.